The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Problem 15 states, a thin-walled hollow tube rolls without slipping along the floor. The ratio of its translational kinetic energy to its rotational kinetic energy without an axis through its center of mass is blank. So, we have a hollow tube rolling without slipping along the floor. So without slipping means all our rotational formulas work perfectly. We don't have to worry about anything funky or fancy going on in those formulas. So we know it's moving at some velocity. Now, our formula for our translational kinetic energy is going to be 1/2 mv squared. And our formula for our rotational kinetic energy is 1/2 I omega squared. Now, what they want is just simply the ratio of the translational to the rotational. So this is what they want. But if you notice, all the answers are given in a number, so we can't just put this over this. What we need to do is we need to get all the variables of each of these to be the same so that the variables are going to cancel out. So basically, a common way to do this is either to change the v's to omega over r, or change omega to v times r, using our formula v is equal to r omega. So a common thing you do in energy problems is just substitute in r omega for v, or you can substitute in v over r for omega. Excuse me if I said that wrong earlier. So what we're going to do is, I generally like substituting in for v. I think it works out a little bit better. You can do whatever you like. Now, I'm going to leave the mass here, and you'll see why in a second. Don't forget, you have to square both the r and the omega, not just the omega, because we're substituting r times omega for v. Both of those end up being squared. Now, this is something you have to look up in your formula sheets that they either give you or you make yourself. I for a thin hollow tube, same thing, I believe they say it is a ring, and through its center of mass, it's just going to be equal to mr squared. So, plug that value in for I, and then I'm going to leave that omega squared. And if you look at this, all the variables are the same, so we're in good shape. Let's write this out one more time, make it a little bit nicer. 1/2 mr squared omega squared is our translational, and 1/2 mr squared omega squared. So you can't see it yet, they're both equal to each other, so our ratio is just going to be 1. But it's no problem if you can't, and you want to, I recommend doing this anyway. Make sure you actually do the ratio. So as you can see, they both have an omega squared, so they cancel. They both have an r squared, so they cancel. They both have an m, so they cancel. And they both have a 1/2, so they cancel. So if you have the same number over itself in a fraction, we know that's always going to be 1. So the ratio of these two is equal to 1. And that is going to be our answer.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.